Now let's take a look here at example number 2. We want to find a power series representation of this function and state its interval of convergence. This will be very similar to what we did back in number 1. In fact, I'm going to ask you to try to see if you can pause the video and see if you could work through this problem on your own. If you're getting stuck or you want to see the full solution, unpause the video and you'll see me begin to work through it. But I'd ask that you try to pause the video now and give this a shot on your own. Okay, so here's where I would start if I was doing this question on my own. I would come here and I would notice, first off, that we can rewrite f of x, which again was equal to this, and that kind of has the shape of an a over 1 minus r. But I might be able to get it there a little bit more closely if I first make the following move. This is actually a really helpful move. Notice I can get a 1 in this bottom left spot very easily by just reversing the order of the addition. And then I can easily go ahead and change this to a 1 minus as long as I change that to a negative 2x squared. So look at how simple that was. Now again, I can see that I have something that appears to be geometric, and it looks like my value of a is an x, and my value of r is this negative 2x squared. So I'll go ahead and I'll write the following. I'll say f of x resembles the sum of a geometric series with a equaling x and r equaling negative 2x squared, again, provided that the absolute value of my r is less than 1. Now I need to go ahead and work through this again to figure out when this is going to be true. And here I have to make sure that I'm careful. I got to think through every step. Again, I can see that the negative doesn't really seem to be relevant. But in addition to that, I could probably also notice that if I have something like a 2x squared and then I absolute value it, I don't really need those absolute value bars, do I? Because isn't 2x squared already going to be positive? So I really just end up with this. Of course, then if I continue to solve, I'm going to get that x squared is less than a half. And when I square root both sides, don't forget that's going to give you absolute value of x is less than square root of a half. So if I was to work with this, ultimately I get down to x is less than 1 over root 2, and x is going to be, have to erase. Sorry about this, I'm trying to learn this new program. It's a little bit, well, just new. A little bit of a learning curve for me. But this should be less than negative 1 over root 2. So this is, again, really, really powerful. And now I can go ahead and reach kind of my final conclusion. My f of x function, which looked like this, is actually going to then be equivalent to a geometric series. The a value is x, the r was this negative 2x squared, and I just have to raise it to the power of n. And of course, I know that this has an interval of convergence negative 1 over root 2 to 1 over root 2. Now a couple things here before we finish up this example. It's important again to note that if you were to go to your calculator and try to graph either of these or both of these two things on this given interval, you would see that they would align perfectly. Now, the other thing that's kind of weird is that sometimes it's hard for us to imagine that this piece over here, this series, is actually going to be a power series where it's just going to be a bunch of x's raised to powers with coefficients. Notice here, here's an extra set of steps I could do to see more clearly that this is just going to be a big polynomial. Okay, I'll just clear out that really quick and rewrite it. But if I was to go ahead and write this down a little bit, you could see that I could re-express this as something like negative 2 to the power of n and x to the 2n. Notice I just took that power of n and I applied it to both things on the inside. And then I could rewrite that one more time by describing how many total x's I have. So if I rewrite this series, I can see that it actually does look like a big, long polynomial thing. If I started writing it out, I would see that I would start to get terms that look like this. If I plug in 0, I'm going to get a coefficient of 1. And when I plug in 0, I get x to the first. When I plug in a 1, I'm going to get a negative 2 x to the third. And then I get like a 4, and I would have x to the power of 5. And then I would get a negative 8 x to the power of 7, and so on. So this is a big, long polynomial thing, even though it is geometric, okay? And has this kind of awkward new shape. So hopefully you were able to get to an answer that looks something like this. Don't be too alarmed if maybe this solving of the absolute value was a bit difficult at first. We'll see lots of things like that, and you can continue to kind of repeat this process here. We just got to make sure we're a little bit careful when we work through that. We don't want things to just be formulaic. We want to try to think and understand what it is that we're doing precisely. Okay. In the next video, we'll take a look at one more example of questions kind of like this to see how we can work with them.